I just said again, we got a educational video. What will we see if we fell into a black hole? Let's get straight to it. The images in this video are based on calculations and simulations.
Welcome back to Science Click. Today, what would we see if we fell into a black hole? A black hole is a spherical region of the universe, a sort of space-time bubble which has an intense gravity. This bubble attracts objects as if it were pulling the fabric of space, not unlike a star or a planet. The surface of the bubble is called the horizon of the black hole. It divides the universe into two regions, the exterior and the interior. Below the horizon, the fabric of the universe is pulled so...
What if it's another dimension? What if it doesn't kill you? What if it just takes you to like a back rooms? Like, well, there's a whole bunch of stuff that's been sucked into a black hole, and there's no damage done to it. Or it's just infinite black and stuff floating.
quickly that nothing, not even light, can escape. Today we know that our universe contains many black holes. They are very distant and represent no danger to us. Nonetheless, we can wonder out of curiosity what we might see if we were to fall into one of them. Answering this will allow us to improve our understanding of the extreme phenomena of our universe, and to rectify a few common misconceptions on the subject. Our galaxy, the Milky Way, hosts in its core a supermassive black hole called Sagittarius A star.
Zodiac signs?
Using a spaceship, we approach it at a reasonable distance, and we jump into the void of space.
Bro, this is literally like a mission to where it's like, get right with God before you go, until you find you a loved one. Because I very much doubt that you're coming out of this alive.
Here begins our fall. It will last
Or maybe you don't die. Maybe you will just float until you starve to death. Or maybe it's another dimension to where it keeps you kind of immortal, in a sense. I don't know.
about 1 hour and will be fatal to us. The spaceship remains stationed, orbiting the black hole and witnessing our fall. Before we even start falling, we run into a problem. The black hole is supermassive. Its gravity equates to a mass millions of times greater than the Sun.
Damn.
With such an attraction, it captures stars and surrounding matter, forming a thick disk of plasma that orbits around it.
It's just like a suction of the universe, bro.
This disk spins incredibly fast, almost at light speed, and loses energy by friction, causing turbulences that heat it up. It thus produces intense radiations, light, ultraviolets, X-rays and gamma rays, which blind us instantly and risk burning us alive. The plasma itself, which can reach several billion degrees, might also well burn us alive. In what follows, we will therefore assume that we are equipped with an extremely resistant spacesuit, which allows us to withstand the heat and filter out any harmful radiation. However,
Yeah, but how would that help in a black hole?
despite the spacesuit,
Would it help or would it not?
the disk still seems extremely bright. We can't distinguish anything. We will therefore imagine that our helmet has a visor, which helps reduce the brightness of the disk so that we can observe it in detail, as well as see the stars in the background.
I'm not gonna lie. Black holes to me are mad interesting. Like they're mad interesting to me. But like, what the hell is in one? Like it's just, I don't know, bro. It's impossible to wrap my head around it because I have no grasp of actual. It's like trying to understand shit that we don't understand when we have no answers to it. It's like you can only make assumptions, but more than likely, I would say our assumptions are probably nowhere near the reality.
At first, we notice that the disk is blue. Within the whole electromagnetic spectrum produced, our visor filters everything but visible light, the light our eyes can see. In this spectrum, the disk emits more blue because this color is more energetic. It is the same effect that gives very hot stars a bluish tint. Strangely, one side of the disk looks brighter than the other. To understand, the matter orbits very quickly, such that on one side it approaches us at high speed, while on the other side it moves away. On one side, the light waves get stacked together, we receive them with greater frequency, while on the other side the light gets stretched, we receive it with less energy. This is called the Doppler Effect. It's the same phenomenon that occurs with sound waves when a car crosses the street. Looking at the black hole, we see that the back of the disk appears warped, as if it were folded around the horizon, forming a ring of light. This is due to
this is the back of the black hole?
the strong gravity of the black hole, which deflects light rays, acting like a gravitational lens.
Well, what if a black hole was like just a hole in the universe? You know what I mean? And it like, cause we know like there's a universe and it's infinite. So what if the black hole is like another dimension inside of like nothingness, and it's like kind of like you see how do I put this, probably some video games or movies or whatever where there's like random ass doors, like freaking Multiverse of Madness, right? There's a random door where they go in, where they open up, and then now they're like in the universe or some shit. They grab the book of whatever, the Shanti, I don't know what the hell it's called, but anyways, what if it's like that, like on some like doors type stuff, but the black hole like says the purpose of the door. It's like a whole bunch of holes to like another dimension, kind of like doors to another dimension of nothingness.
Looking in
And you
one
get close to it, it
direction,
sucks you into
we
it.
observe objects that are actually located elsewhere. Finally, the stars in the back.
Its movement alters. So it's like, if I understood that correctly, which I don't know if I did, I probably didn't. So like in a sense, it's like someone looking at the horizon, right? And it's like we think we're looking straight, but really the earth is curved. You know what I mean?
Ground seem ever so slightly blue. We do not feel it, but the black hole distorts time, such that our clock turns slightly slower than that of distant stars.
Time travel! Although I think that realistically time travel probably would be impossible.
Compared to our clock, the light from the stars seems
I
accelerated.
think it's a cool concept, but I think realistically, but I mean, I'm not educated in any sense on any of this stuff. I just think this video is interesting, but I think time travel, if I had to assume, if I had to just say something about time travel, I think it would realistically be, I don't know, it's like, to me it would be unrealistic, but then again, in a sense, it's like, if you look at, if you are on another planet, like say like aliens are looking down at us, right? Or from another planet, like billions light years away, like they would see dinosaurs. In a sense, it's time travel, ain't it? But like we can't, like it's crazy because like if they had like a good enough telescope or whatever, they would see dinosaurs, right? But there's actually people. So in a sense, wouldn't that be time travel? That's because to me that's really interesting how that works.
To the extent that we see it bluer than its original color. Surprisingly, during the first 10 minutes of the fall, the black hole appears to be moving away. We are moving closer and closer to it, but its image seems to shrink more and more.
Probably warps your eyesight like it did before. Like when you look straight, but it's actually curved. Like you see something on the other side instead of, yeah.
Imagine throwing a ball through a car. The ball is thrown at 90 degrees and crosses the car side to side. The passenger sees the ball travel across the car at 90 degrees. But imagine now that the car is moving. This time, the passenger sees the ball coming from the front with a narrower angle. Because the car is moving, objects reaching it seem to come from a different direction, more from the front. In our case, the situation is analogous, only with light rays instead of a ball. We receive the light of the disk from a certain direction, but because we are moving towards the black hole, the rays seem to reach us from a different direction.
Yeah, I don't understand any of this.
Squashed towards the front. This is called aberration. After these first 10 minutes, we are now falling very quickly, at 4% the speed of light. And from this point onwards, the black hole starts to grow in our field of view. As minutes go by, we gradually descend towards the black hole. Our speed increases and we receive the light in front of us with an increasingly high intensity, while the light behind us seems to get darker.
Huh!
This again is the Doppler effect at play. When falling towards the black hole, we catch up with the light in front of us, while the light behind us has more difficulty reaching us. If we turned around, we would notice that the clock inside the spaceship seems to be running slower than before.
But space is time travel. Like space has to be like, if there were to be time travel, even though I think that from at least our understanding, well, I think I don't know. From the understanding that we have now, probably I think that it's unrealistic. But I don't know. I think like from what he said, like time slowing down, bruh. Like that's like time travel. I mean, because he's going. Well, he said 4% is the speed of light. So he's going fast as fuck. But it's not in the same range of actual time. I don't know, to me space is like time travel, bro.
The effect is subtle, but still noticeable. This is also due to the Doppler effect. If we imagine that the clock emits a signal each second, these signals take longer and longer to reach us, and we thus observe the ticking in slow motion. Minutes pass, and we gradually fly over the disk of matter.
I would assume that realistically you'll probably be dead by this point.
Suddenly,
Because isn't this shit supposed to be really, really hot?
after 57 minutes of falling, the disk seems to fade out.
Like when it like he said like this shit's supposed to be really, really hot, right? So if he goes through that, wouldn't he like probably just realistically burn up? Like he would be dead before he even
We
gets to
have
the
just
black hole.
reached the point beyond which matter can no longer orbit the black hole steadily. The gravity is so intense that at this distance, the plasma begins to spiral very quickly into the black hole. Things will now get much faster.
So things will get much faster, but time gets slower, right? It's crazy. It's time travel. To me at least. My
Just 2
uneducated
minutes
ass.
later, we are twice as close to the horizon. From now on, any light coming from outside is destined to fall into the black hole. This is called the Photon Sphere. At this precise distance, it's even possible for light to orbit the black hole. As we approach more and more, the passengers who remained in the spaceship see our image fade and gradually slow down until freezing on the horizon. The light that we emit takes more and more time to escape the black hole. It is received increasingly slowly and gradually fades away. The passengers will never see us cross the horizon. But for us, just 24 seconds after crossing the photon sphere, it is time to reach the horizon. After this moment, it will be impossible for us to go back.
Yeah, you'd
But
be dead.
what do we
Yeah, you. That's why I said like you. Well, I don't know about dead, but if I understood correctly what he had said before, the stuff that he had that you have to pass through to get to the actual black hole is like really, really, really hot. So I'm assuming that you wouldn't even be alive to even get into the black hole, quote unquote. I feel like you would burn up on the way to the black hole before, like, 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 like a human falling from orbit. You know what I mean? Into onto Earth, like you would reach. I don't know.
see when crossing the horizon? Surprisingly enough, nothing special. It would in fact be very difficult to determine when exactly we cross the horizon.
Bro, we need a movie with like someone falls into a black hole.
Still receive the light of distant
Put Tom Cruise as the main actor,
which falls with us. We can still see the spaceship in orbit, in which the clock, even if it seems slowed down, is still ticking. And we can still perfectly see our body, and in particular our feet, because even if all light is carried inwards, it can still move upwards relative to us and thus reach our eyes. This is actually a fundamental principle. On a global scale, space-time is curved by the black hole and generates this horizon inside which objects are disconnected from the outside. But at the local scale,
right?
space-time is almost flat and the curvature is not noticeable, which means that everything behaves normally. Furthermore, as opposed to what one might think, the image of the black hole does not appear to encompass us at all. Even if we are now inside the black hole, its image only takes up 15% of our field of view. The rest is still filled with stars. This is again due to the phenomenon of aberration. Now that we move extremely fast, the light that arrives from the sides and even from behind seems to come from the front. Our field of view is contracted ahead of us and widened behind us. In particular, the spaceship behind us seems to grow larger, even though we move away from it. We have crossed the horizon and nothing special has happened. However, from now on, if we try to send a signal to the outside, it will never reach its destination. Below the horizon, everything is destined to fall downwards, with no hope of ever coming out. But for the moment, everything is fine. It is after another 30 seconds,
I find it very hard to believe that you would be alive by this time.
Just before reaching the center of the black hole,
Probably would fucking die of a heart attack, because literally your life is more than likely over.
That in the blink of an eye, we feel an incredibly powerful force that stretches us until dislocating our body. This is called spaghettification. Our head being further from the center than our feet, the difference in pull is such that our body is very quickly torn apart. In our
you wouldn't even make it in there.
very last moments, we have the impression of falling onto a flat surface, as if we were reaching the surface of an entirely black planet, while a circle of light intensifies all around us.
You're dead. Yeah, it'd be suicide mission.
1/10 of a second later, the shredded remains of our body reach the center of the black hole. Our journey ends here. For the moment, modern physics cannot describe what happens this close to the center of a black hole.
Exactly. Like, this is... There's an explanation for everything. But that explanation sometimes is not understandable to us as humans. That's why I would say this is God.
Our current
Not saying the black hole is God. I'm saying like he created that. And
theories
he is beyond our understanding. And this is beyond regular physics, so I'm guessing this will be, I don't know.
describe singularities, points where the curvature of space-time becomes infinite. But scientists suspect that these singularities do not really exist. We would have to unify gravity with quantum physics if we wish to understand these extreme regions
Quantum realm and time travel, yes.
of the cosmos. For now, some hypotheses
Marvel shit.
even question the
Endgame
fact
type
that
stuff.
one could survive
Infinity War.
crossing the horizon.
No,
Moreover,
that's Endgame, yeah.
in reality, black holes can have an angular momentum, which generates strange effects with multiple horizons and mathematical instabilities whose consequences we do not yet understand.
I think I don't know how we would ever actually understand this. I mean, shit, who knows, right? Like, I mean, maybe in 100 years we will, 100,000, you know? But
That
this
said,
may just be one of those things that is like God. It is out of our. I'm not saying that this is God, but God. To me, God created this. So this is one of these things to me where it may possibly be something that is out of our comprehension of understanding.
our current theories still give us a good idea of
Because you fucking die. Like you die before you could even test further. Like
what we would see. In particular, we can correct a few widespread misconceptions.
I mean, even finding a black hole would take probably years and years and years of space travel.
For
Unless you freaking get on some Star Trek type shit and like start going the speed of light.
example, the disk around a black hole is not orange, but blue. If some images show it as orange, this is because they use false colors, which are only intended to represent luminosity, but not the real color in visible light. Another idea that is widespread is that we would observe the whole history of the universe unfold before our eyes, while our field of view would get engulfed by the black hole. This is
That would be fucking insane.
also wrong, as it forgets to take into account the Doppler effect and the aberration of light. There are, however, many mysteries left to solve, and we will have to wait until our theories are perfected to understand what truly happens.
Who knows? I don't know. I mean, I'm not even educated enough on this stuff, but I don't know if we would ever even have this level of understanding. Maybe one day, I don't know though.
Heart.
Like this, like I said, might be one of these things where it is out of our level of understanding as a human. Like we are incapable of understanding this.
Real black hole.
Like it is maybe not meant for us to understand. It's just I don't know. But maybe I don't know. Shit, I don't know. Alright, JCRI gang, that was a very interesting video. I did enjoy that. That was cool. I actually did like this. That's something that interests me, like the black holes. But yeah, anyways, y'all. Falling into a realistic black hole VR 360. Yeah, no, that's hard to take. Anyways, you have a blessed one, guys. With you guys who not put anything in life you can handle. It's been JC. Y'all take care. Later, y'all.